For this example involving some data and a least squares regression line, we're really going to focus more so on part B, finding the equation of a line given two particular points. So there's a process here when doing so, and the first thing that we want to do is find the slope between the two given points. The slope formula that we use with 2 points is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If needed, you can label the 2 points that you are given with those parameters x sub 1, y sub 1, x sub 2, y sub 2. The subscripts here just mean that they come from either the first point or the second point. So with that information, let's now plug in the values that we have. Y sub 2 is 5, y sub 1 is negative 2, so this would be 5 minus negative 2. X sub 2 is 2, x sub 1 is negative 2, so plugging that in, we would have 2 minus negative 2. Because we're subtracting a negative, that's really the same as adding. We get 7 over 4, which could further reduce to 1.75. And you see that that's already part of this final answer here as well. In the next piece, now the next step rather, is to find the line between the 2 points. So we now have slope. This slope is now going to go here in this equation. And notice that this equation for a line also refers back to one of the 2 points. Now we're going to use x sub 1, y sub 1, and I've already labeled x sub 1, y sub 1 both as negative 2. But technically I could have used the second point. Just in the future, if you look at it and say, I want to use something a little bit easier with less negatives. So plugging this in, we have y, the variable y, so I'm going to leave that as y, minus negative 2, that's the value for y sub 1, equals the slope, 1.75, times x minus the value for x sub 1, which is negative 2. Again, x here is the variable in the equation. X sub 1 is a particular x coordinate of 1 point on that equation of the line. From here, we'll just clean this up because when I look back to the equation itself, notice that it has been solved for y. So that means I could rewrite as such. So minus a negative is the same thing as adding a positive. I can distribute the 1.75. Well, first, actually, let me clean this up. This would be x plus 2. Now let's distribute the 1.75. So distributing the 1.75, we get 1.75x. And then 1.75 times 2 is plus 3.5. Lastly, to get y completely by itself, I need to subtract 2 from both sides. And I end up with y equals 1.75x plus 1.5. Those are the values that you're going to put here into the equation of the line, and they do represent something special about the line, each of these values. We already know that the 1.75 is the slope, just the 1.75, by the way, not including the x, but the x helps us locate the slope. And the other thing special that we have here is this positive 1.5. This is the y-intercept of the line.